So far, we have discussed several concepts and then examples to identify how AI has actually helped and understand, and then using problem searches, spaces, and so forth. Another set of interesting problems, Sudoku. I'm sure you've come across that problem. Okay, can we build a system that can actually solve this problem? So this is where AI is now. AI stands trying to understand human behavior, intelligence, and see our application, the mental abilities that we understand, and copy them, and then see if we can play those games. We can define, we can actually make those games. Some of the most popular problems or games, so to speak, okay, in AI that have been very interesting, people have found a lot of interest in them. One of them is chess, for instance. Okay, apparently straightforward problem. It's not. Okay, you have 8 pieces on one side and 8 on the other, and you have a board which is 8 by 8, 64 positions, right? Each person has the option of moving from one position to the other. Now, remember, in terms of the solution space or the operators or the legal moves and the solution itself, okay, apparently it's pretty straightforward. Solution itself can have several, states, in the sense that as long as the king is under attack and it can't move anywhere else, okay, it can't be protected. Now, this situation can happen on several board positions. Now, each one of them is actually a solution. How do we get there is what the game is all about. Okay, representation is pretty straightforward. Okay, so chess has been, a lot of interest has generated. Another one mostly cited in AI circles is the traveling salesman problem. What exactly is the traveling salesman problem? The traveling salesman problem is that the salesman has to visit several cities. Okay, he starts from, let's say, Lahore, he has to go to Karachi, Islamabad, Peshawar, Faisalabad, Hyderabad, and so forth. And each city, there's a cost associated with it. It can be time, it can be the road distance, it could be the ticket or the cost, and so forth. The problem is that he must visit each of these cities at least once, and find out the sequence that he has to go through, starting from, let's say, Lahore, okay, and minimum visit once to each city. Now determine which route he must take so as to reduce the minimum distance, cost, time, or whatever. A very typical problem. And this, once again, this problem can be represented in a problem space kind of situation. We have a Tower of Hanoi problem. Very interesting. We come to that. Water jug problem we have discussed. Okay, and there's an N queens problem also. Each of these very interesting and intriguing. Okay. So what is the Tower of Hanoi? I've discussed the Tower of Hanoi problem. Okay, is you're given a set of discs. Okay, as you can see. So you have 3 spindles on which these discs can be mounted. You're given a condition, you give initial state, you have the red at the bottom, the green disc in the middle, and the blue one at the top, okay, in a sequence, small and then bigger and the bigger. Your problem, your task, okay, is to move these discs so that the middle spindle has the same arrangement, which is red at the bottom, green in the middle, and the blue at the top. That's your solution that you want to achieve. So let's see what happens in simple steps. You move the blue disc to the middle. That's step 1. You could move the blue disc to the right as well. So that's another situation that can happen. But in here we see that we decide, okay, that we move the green disc from the left to the far right. Okay, so we left with red on the left, blue in the middle, green on the right. Then let's see what options do we have. So what we do is we actually move the blue on top of the green, because it won't allow you, what's not allowed is putting the bigger one on the smaller one. So the only option is to actually move the blue on top of the green. Now there's the one in the middle, that spindle is actually free, as you can see. The only thing left is now moving the red. So move the red to the middle. That's part of the solution. The solution is, in the middle spindle, you have red and then green and then blue. So you've actually partially come to a solution, but it's not fully complete yet. In step 5, you move the blue one from the right spindle to the leftmost. So now the situation is blue on the left, red in the middle, and green on the right. Right. And I think if you look ahead a little bit, you can see that we have actually reached the problem, reached the solution. Okay. All we have to do is move the green on top of the red one. And this is what we do. That's step 6. Okay. So we are now halfway, 2/3 of the problem has been resolved. And all we now have to do is move the blue on top of the green. And that's what we do. So in about 7 steps, as you can see, we have come to the solution of the problem. So the thing we're trying to learn here is that there are strategies of moving and playing around in the games. Remember the tic-tac-toe? In the tic-tac-toe, okay, you have noughts and crosses, and you need to put them. There are about 9 spaces. By experience, I'm sure you realize that if you come to a certain position on the tic-tac-toe, right, you're absolutely sure that you're 1 step short of success if you can get there, right? So if 2 good players are playing, they will try and reach that position. So what you're doing is you're learning by experience, and you set your choices, your pieces accordingly. Likewise in chess as well. And that's a battle that happens. I want to beat the other player by putting his or her king in an indefensible position. So I have to attack in several positions. On the other side, the opponent is actually doing the same thing with my king and queen. And that's a battle. Okay, so my positions that I've thought of, and his position that he has thought of, to beating me, which is checkmate, is something which actually, that's what the game is about. So what we've done is we've discussed several things. I hope you find these interesting, and perhaps look them up and enjoy what we've learned so far. Thank you so much.